Hello everybody and welcome back to another video. In this video, I will be covering an interesting torque problem from the 2018 F equals MA physics competition. Now, in this problem, you have two massless rods which are attached to frictionless pivots. Their ends are touching and the distances are shown in the picture below. In this system, there is no friction and a force F is applied on the left downwards, and it is asking what force F prime must be in terms of F in order to keep this system in equilibrium so that it is not rotating or moving at all. Now, to get started, let's look at the basics of what a torque is. So torque is equal to force times the distance the torque is away, the distance the force is away from a pivot. However, it is not that simple, as what if you apply a force at an angle? Then we would just want the vertical component of this force, so Fy in this case, and this is R. So you get T is equal to the magnitude of the vector F times the magnitude of the vector R times sine of theta. Now, as this angle right here leads to the vertical component, which is equal on both sides, so this is Fy, so F times sine theta equals Fy. Now that is not necessary for this problem. I was just showing you what a torque really is. Now let's get started by writing the net torque system for this part of the system right here, which must be equal to 0. So we have T net is equal to this force right here, which is 2 meters away. So we have 2 meters times this force F. Then there's a force from this beam right here, which we will call F2, which is 1 meter away. So we have, and they are in opposite directions, as this is trying to rotate it this way, and this is trying to rotate it this way. So this is 2 times F plus 1 times F2 is equal to 0, as this must be in equilibrium. So then when we rewrite this, we get 2F plus F2 equals 0, and we get 2F is equal to F2. And now we can work on the right side of the rod, where we have this same F2 being applied 0.5 meters away, and a force F prime being applied 2 meters away. So our net torque equation for the bottom part is equal to 0 Newton times meters, which is equal to 0.5 meters times F2, and then that is minus 2 meters times F prime, as they are in opposite directions. And when you add 2F prime to both sides, you get 2F prime is equal to 0.5 F2, which is basically just F2 over 2. So when you multiply this by 2 and then this by 2, you get 4F prime is equal to F2. And up here we had that 2F is equal to F2. So we can replug this in for our F2, and we get 2F equals 4F prime. And when we divide by 4 to get F prime by itself, we have F prime is equal to 1/2 of the original force applied. And now when we look at our answers, we see that that is answer choice B. So that is the answer for that question. Here's all the work. It is a very simple problem. I just find it very interesting as it is really all that torque is about. It's a great torque problem, and it's great for genuinely understanding what is going on. Anyway, I hope you all enjoyed this video, and thank you for watching. Please like and subscribe, and catch you in the next one.